So we'll start a new lesson in real numbers. The first problem is show that any positive odd integer is of the form 6q plus 1, 6q plus 3 or 6q plus 1 where q is some integer. So, so what is the given? So we have to get, so it is positive odd integer. So as per the Euclid's theory, A is equal to BQ plus R, where R is less than B. Now let us take first example. A is equal to 6Q plus 1. So here 6 we can write as 3 multiplied by 2 multiplied by Q plus 1. So this is an even number. When you add 1, it becomes odd number. So this even plus 1 becomes odd number. No, this is true. Similarly, when 6q plus 2 is there, 6 first 6q is even number, plus again 2 is even number, result is even. So this we are not taking. What will happen if you take 6q plus 3? So even plus odd, the result will be odd number. Similarly, 6q plus 5 will be odd number. What about 6q plus 4? It's certainly a even number. So let us apply this formula and get all the odd digits. Okay, the first you take it as, so no, these three we have put 6q plus 1, 3 and 5 are odd integer. You put q is equal to 0, then we will get, suppose say q is equal to 0. So then what numbers we get? 1, 3, 5. If q is equal to 1, then we get 6 plus 1, 7, 9, 11. If q is equal to 2, we get 13, 15, 17 and so on. So we'll go to the next problem. Use Euclid's division lemma to show that square of any positive integer is either of the form 3m, 3m plus 1 for some integer m. So here the question he gives a clue. So the answer should be of the form 3m or 3m plus 1. It is given. So as per Euclid's formula, A is equal to BQ plus R, where R is less than B. In this case, A is equal to, what is B? B is 3, it is 3m. First we will take the case of 3, what A is equal to 3m plus R is plus 0 rather. If you square, what happens when A square? A square is equal to, we will make a say for 3 multiplied by this 3 and m square, so it is 3m square. So this is of the form 3 and some quotient q. This is of the form 3m actually. 3 into some quotient. we'll take the next case. What will happen if A is equal to 3m plus 1? So A square is equal to 3 multiplied by 3m square plus, here we get 6m, if you square it. So 3 multiplied by 2m plus 1. What happened now? This is of the form 3 multiplied with some quotient. So m is integer square, add something, you get some quotient plus 1. This is of the form. But see, 3m plus 1 we have considered, the 1 plus 3m plus 1 we have. What about m plus 2? If a is equal to 3m plus 2, a square is equal to 3 multiplied by 3m square plus 2m. Here we get plus 4. So this is now so 4 is greater than 3. So given is or should be less than b. So this won't be a fact. We can of course write in the form of 3 multiplied by 3m square plus 2m plus, we can rewrite plus 1. If you take the 3 out, plus y. So again it becomes category of first one, 3m plus 1. These are the form 3m plus 1. It is not 3m plus 2 or 4. So the first two are the answers. So in applying Euclid's division lemma, we have to bring the formula in the form of Euclid's division lemma, so that the unit, we are able to apply 3 multiplied by some quotient. We can express in the form of 3 multiplied by some quotient plus remainder. Next problem. For the certain fraction, that following fractions are terminating or not. So in the first we will check whether the decimals are terminating or not, and then we can actually work it out. Check now 17 divided by 8. If we divide by 2, it is 2.125. And what is the denominator of the form 17 divided by? It is 2q. So therefore denominator is of the form 2 to the power m and by 5 to the power n. Here it is 2 cube multiplied by 5 to the power 0. So it's terminating. Denominator is the form. So we are able to get the answer. Next problem, 64 divided by 455. So it is numerator category 8 multiplied by 8, you can take 64 divided by 455. We can take it as 5 multiplied by, it is 91. So the denominator in this case, denominator is, see, 5 is odd, this also odd, 91 is odd. So denominator is not of the form either 2 to the power or 5 to the power. So therefore its decimal is not terminating. So if we actually divide 64 by 456, we get something like, we can just divide and check. The answer is something like 0.140 0, 5, 9, 3, something like that. It comes, it repeats, it continues like that. So next problem is 15 divided by 1600. Now we can now reduce divide by 5 both sides. It is 5 multiplied by 3 divided by 5 multiplied by 320. So you can cancel the common factors. It is 3 divided by 320. So we can write this as, so we have, so is it divided by 5? You can again divide by 5. 5 multiplied by 64. 64 we know it is 2 to the power of 6. 3 divided by 5 multiplied by 2 to the power. So denominator is of the form of 2 to the power m multiplied by 5 to the power 1. So decimal is terminating. So we can find out by actually dividing. 3 we can divide by 320. We can get what is it. So next problem. So shall we try dividing like this? If you divide 3 divide by, or we will take 320, we have to take point 0, we have to add 1 0, add one more 0, one more 0 here, one more 0, yeah, and you have to go on divide. It's, so we'll try now with 9. 9 2s for 80, 1, 9 3s are 27, 128, we minus, we get 120, add one more 0, make it 3, 3 times it is 960, so if we minus we get 240, we add one more 0, minus, it is 7 times, is 240, so we'll get 160, now we may get 5 times, 1375, it terminates here, minus. So we can work out one more problem. It is 13 divided by, what is 3125? So we can write, this, if you divide by 20, 25, divide by 25 multiplied by, it is 64. Sorry, it is not 64. It is 25 multiplied by 124. 125. We will try with 125. Because 100, if you divide by 24, it is 4. Here 31 hundreds are there. 124 multiplied by 4 is 124 plus 1, 125. You can write this as 5 square into 5 cube, or you can simply write as 13 divided by 5 to the power 5. So decimal is terminating. 13 divided by, So what is the answer comes something like this. You can try 0.00411216. So the next case, it is 29 by 343. So denominator 343, how we can write? So it's odd number not divisible by 5. Therefore, the decimal is not terminating. Now, 29 divided by 343. We work out, we get a very odd number long. We can please make an attempt. This problem is repeating. I will just score off one of the problems. Now 23 divided by 2 cube multiplied by 5 square. Now it is clearly given. This is decimal is terminating. So it is 23 divided by 2 cube is 8 multiplied by 25 is equal to 23 divided by 200. If you work out, it is 0.115. So we can divide like this. 23, we add 1 0, is 200. Now it's 300, 1, 5. So as per the theorem, it is of the form 2 cube and 5 square. So as per the theorem, decimal is terminating. Now we have also proved it. So we'll try some more problem. What is 6 divided by 15? This now first common factors we have to cancel. 6 divided by 15 divided by 3 is equal to 2 divided by 5. This is simply 0.4. So it is terminating. This we have got decimal terminating. So we'll try some more problems just to get used to it. What about 35 divided by 50? So cancel 5, 7 5s are 35, 10 5s are 50, 5 get cancelled. 7 by 10 is simply, it's 0.07. So this case denominator is of the form 2 multiplied by 5 to the power of some m to the power of 1 multiplied by 5 to the power of 1. Therefore decimal is t, terminating. So we'll try one more sum. 77 divided by 210. So 77 is 7 multiplied by 11 divided by, what about this one? 7 multiplied by 30. 7 is the common. You square it off. What about this next is equal to 30? We have to express in the form of 2. 2 multiplied by 3 multiplied by 5. So this is not terminating. Why? Denominator is not of the form 2 to the power of m into 5 to the power of n, because you are multiplying again by 3. So therefore it is not terminating. We will also take it out. Now 11 you divide by 30, 0 point, you add 0, 3 threes are 9, 20, now we add 1 0, 6 threes are 18, 180, now we get 200, again 6, like 666 you are getting, so it's not terminating. This 200 will get repeated and will continue. So in this chapter we have seen how the new Euclid's formulas are applied, theorems are used in proving. So it is very significant, show that for any odd integer, the formula, the answer is given in the question, actually in the first question. So now we know how the numericals are developing as per the Euclid's formula, how it unfolds. And the fractions, whether terminating or not, will be very useful in many scientific problems. Oh, thank you for listening patiently. You please go through some problems and try to work it out whether actually it's terminating or not. That will help you to understand whether the fractions are actually terminating and how. Thank you for listening patiently.